The next example, we're going to look at non-parametric distributions. Non-parametric distributions are those that are not parametric, of course. Parametric distributions mean a theoretical distribution like binomial, Poisson distribution, Bernoulli process, or in continuous side uniform, exponential distribution, PERT distribution, normal distribution. So if our data is such that none of the parametric or defined theoretical distributions fit our data well, then uh, we have two possibilities. Okay, so non-parametric distributions are used when the parametric distributions do not provide a good fit. Now, for example, multimodal distribution for hybrid engine, um, miles per gallon. So that's the example. So we will look at that in just a second. And then we have two alternative approaches in such a situation. So one is called Riskcumul distribution. So that is a cumulative distribution, a discrete cumulative distribution that you can fit to the data. So in other words, it will be like a frequency distribution, and that closely resembles the existing data, and we use that. Or we have a risk splice distribution where portions of the data range may follow a parametric distribution. So you have one parametric distribution for one data range, another one for another data range, another one for another data range, and so on. And you stitch them together or splice them together. So that's risk splice. So we will look at both of them. So, but first let's look at what kind of distribution we have for the existing data. So we'll head on over to Excel. Okay, so here is the hybrid engine MPG. So we have like 3,884, 883 values. So you go to at risk and then you say fit. Okay, so here is the data, hybrid engine MPG. Okay, so all right, so click OK. So then it gives you this distribution. Okay, the distribution that at risk finds is a triangle distribution. That's the best with the AIC criterion. But as you can see, that's nowhere close to the actual data. The actual data seems to have three modes. There is one mode here, there is another mode here, and another mode here. So this triangular distribution is not good. So let's take that out, and let's say so. Let's go ahead and copy this graph over here so we can have a look at it without having to get into the at-risk system. So now we're going to write this triangular, the best one that at-risk has found, so for the purpose of comparison. So we'll put that best single fit over here. So write to Excel. Okay, so we're going to put it there. So that's the best fit at-risk has found. Okay, so now we're going to do non-parametric. So non-parametric is you can define the function. Either you can go to function and do it, or you can do it from distribution. Okay, define, and we have risk. Let's select all. So there it is, Cumule. Okay, so for that we have to provide a minimum value and a maximum value, and then a table of x values. So that will be the table of miles per gallon and the corresponding cumulative probability. Okay, so the cumulative probability should look something like this. So we have to set up that table and then be able to input that here. So let's cancel out. So we have to set up the minimum value. So minimum value, you can get the minimum value from the actual data, or you can specify your own minimum value that is less than the minimum value in the data. So you can specify it yourself if you like. Okay, and then we want to set up. Okay, let's say that we want to set it up in increments of 5%. So we are setting up percentiles of the data. So the more granular you get, more close your defined distribution will be to the actual data. So instead of 5%, you can say I'm going to go in increments of 1% or even 0.5%. So the granular you get, the smaller percentiles increments that you provide, more granular will be your data arranged and more closely your fit will be. Okay. Of course, when you do too much, then you start fitting the noise instead of the data that we have. So we end up replicating the data instead of using the data as a kind of a template to generate random values. Okay, so you have to be careful. Not you could too little is as bad as too much. So we'll go in increments of 5%, and then finally the max value that we have to enter. So we can enter the max value easily. Again, you can just select the max value in the data, or you can specify your own maximum value. Okay. Now after that, what are the percentiles, the 5th percentile, 10th percentile, and so on in the data? So we can use percentile. Okay, you don't have to use the risk percentile. If you have risk percentile and then risk theoretical percentile, but we can use the Excel native percentile. Excel native has 2 percentile functions. Okay, and these two are legacy functions. That's why you see a warning sign here. So don't use the legacy functions. Use one of these two. Depending upon which one you use, you may not get a valid value at the extreme. Okay, so like 0% or 100%, you may not get a good value. So you have to adjust for that. So let's say we select percentile.exe. Usually percentile.exe will be closer to what actual percentile is. So all right, so now let's go and highlight the data, and we need to press F4 because we need to be able to copy this to the rest of the cells. Okay, and then the percentile that we want. Okay, so there you have it. Okay, so now you copy that all the way. Okay, so now for the 100%, it's not giving you a valid number. So you can try a number that's slightly smaller, say 99%. Okay, and let's have format that. Okay, and then we have to find the cumulative probability, theoretically cumulative probability at each of those percentiles. So we could simply say it's 5%, 15%, like this, no, not 15%, sorry, 10%. So this can be our cumulative probability, but we can do a little bit of adjustment to come up with a theoretical value. So that will be n divided by n plus 1. So how many observations there are, okay, divided by how many observations plus 1. So you go that, it's probably better to put that in a separate okay, let's do that. So let's say the n equal to, and then n plus 1 equal to, right? So n equal to will be count of that, okay. Now n plus 1 is that plus 1, okay. The cumulative probability is given by, okay, within parentheses that, well, let's do that also. So we'll have n divided by n plus 1, so that will be n divided by n plus 1, and that's the adjustment that we make to the cumulative probability to make it more smooth, not exactly the same as the data. So you do E2 times that, and that should be absolute reference. So this gives us the cumulative probability for this hybrid MPG value. Okay. So we will be specifying in at risk what the minimum value is and what the maximum value is, and then this will be the X range, this will be the probability range. That would set up a risk cumulative probability that fits the data, and it's not a theoretical distribution that fits the data. Okay, we'll do that in the next video. Okay, so now that we have the minimum, okay, let's do this. Okay. All right, so now we go to distribution, define, cumulative, select that distribution. Okay. Now, minimum is that, okay, maximum is that. All right, now X table, well, all right, we need to be able to highlight, so that's the X table, okay, not including min and max, and corresponding with that, okay, so the probabilities are these. Okay, so now we have the cumulative probability setup or risk cumulative. Okay, so now we click OK. We need to select where the non-parametric risk cumulative distribution should go, and then define risk cumulative, okay, and then the minimum value is that, maximum value is that, then the X table value, or these, not including the minimum and the maximum, okay, and then the probabilities. All right, so now that sets up our cumulative. All right, so then click OK, and that cumulative probability distribution is inserted there. Okay. So now let's look at splicing.